Good morning, everyone. I want to welcome you to the first of the talks after the plenary talk this morning by Margaret Torn. This morning, we're kicking off with Carolyn Szum from LBNL. Carolyn is a program manager at LBNL with 17 years of experience in energy efficiency market transformation, also in remote building energy analytics and climate finance. She's the winner of a 2019 Keeling Curve Prize for innovation in climate finance, and a 2020 R&D award for the software that we're going to be talking about. Prior to joining LBNL, Ms. Szum was a leading managing consultant at ICF, where she led energy efficiency projects for the U.S. Department of Energy and the U.S. EPA, as well as the U.S. Department of State, USAID, and the World Bank Group. She served on the Hong Kong Business Environmental Council and was co-chair of the U.S. China Energy Cooperation Program for energy efficient building design. She has an MA in International Relations from the Fletcher School of Law and Diplomacy at Tufts University, and speaks a wide number of languages and has worked in quite a number of places. I encourage you to find a better acronym when we're here at the BEST Center, and we found Building Energy Targeting Tool for Energy Retrofits. Best and better, we gave up looking for good. We have it all right here. So Carolyn, without further ado, let me hand it off to you.
Thank you so much, Janie. So thanks everyone for joining today's webinar on the Building Efficiency Targeting Tool for Energy Retrofits. Today's agenda, I'm going to do a brief introduction to the Better web application. I'll go in depth on the analytical engine. I'll do a live demonstration and discuss our pilot activities, and then we'll have time for question and answer. So before I begin, I'd just like to acknowledge the U.S. Department of Energy Office of Energy Efficiency and Renewable Energy, Building Technologies Office, which sponsors the development of Better. I'd also like to mention that Better is being developed under a cooperative research and development agreement, a CRADA, between UC Berkeley, Lawrence Berkeley National Lab, and Johnson Controls, with additional assistance from ICF International. So I'll begin by discussing the U.S. building market, challenges and opportunities today. As many of you may be familiar, the U.S. Department of Energy Building Technologies Office in particular has set forth ambitious goals to reduce U.S. building energy demand by 2030 and by 2050. Their long-term goal is to reduce the energy use per square foot of U.S. buildings by 50% compared to 2010 levels, which means that we need to reduce building energy use intensity by 30% by 2030. What's more, the U.S. building stock is an aging building stock, and it's sorely in need of retrofits. By 2030, more than half of U.S. commercial floor space will have been built before 2014 and be in need of an energy efficiency retrofit. However, preparing buildings for retrofits can be complex, time-intensive, and expensive. Preparing buildings for retrofit requires carefully defined and calibrated models, often combined with on-site energy audits, which are particularly difficult to implement at this time of the COVID-19 pandemic. As a result, the upfront work and cost can be prohibitive for many building owners, even when energy efficiency retrofits can be cost effective. And finally, I just want to mention that while we see important advancements in smart metering and advanced metering infrastructure, less than half of U.S. electricity customers have access to this technology, and the majority of electricity customers are using monthly utility bills to manage, track energy performance in their buildings. So it's within this context that Lawrence Berkeley National Lab partnered with Johnson Controls to introduce into the U.S. market a very easy-to-use web application to target efficiency improvements by turning readily available monthly energy consumption data into specific measurable energy efficiency measures, both operational and technological, at the building and portfolio level. The tool I'm going to talk about today, Better, I think it's important to mention up front, it's not a virtual auditing tool. Better is intended to help capture energy efficiency opportunities in existing buildings by providing a preliminary estimate of the size and makeup of potential energy efficiency projects. What's more, Better is highly scalable. One of the advantages of this web application is it can be used to target efficiency opportunities in one or many hundreds of buildings simultaneously. So it can be used in corporate portfolios, city portfolios, etc. Better is not a rating tool. It doesn't provide a score or a path to certification. And it's designed to be highly complementary and interactive with U.S. Department of Energy's existing tool set, including products like Asset Score, the Standard Energy Efficiency Data Platform, Building Sync, and of course, U.S. Environmental Protection Agency's Energy Star Portfolio Manager tool, which is being used by more than half of U.S. Commercial space to benchmark performance. So with that introduction to Better, I want to give you an overview of how Better works to, again, target and prioritize energy efficiency opportunities in buildings and portfolios at speed and scale. Better takes in basic building data, and I'll talk a little bit about the data required to run Better in a moment. Weather data from the National Oceanic Atmospheric Administration database, and energy consumption data, so the monthly utility bill information. Better pre-processes this information and develops inverse models or change point models for each and every building entered into the analytical tool. For those of you who are familiar with the ASHRAE Inverse Modeling Toolkit, you'll be well versed in inverse modeling, also referred to as change point modeling. But essentially what Better is doing is very quickly creating plots for each and every building, whereby the average daily energy use intensity for a building for any given month, or for the past 12 months, the past 24 months, the past 36 months, is compared to the average daily outdoor air temperature for that same month. And as a result of those plots, Better will fit a model. In this case here on the overall workflow graph, we're looking at a 5-parameter model. And I'll talk in more depth in a moment about the different models that Better can create and how it derives information on the performance of the building in terms of energy, as well as energy saving opportunities related to those coefficients. But for now, I'll just mention that Better creates these models and develops, and then identifies up to 5 model coefficients for electric consumption in the building and up to 5 model coefficients for fossil consumption in the building. These include baseload consumption, the heating and cooling change point for a building, and the heating sensitive consumption and the cooling sensitive consumption for a building. Again, we'll go into more depth on those later. I want to give just a high level overview now. Once those coefficients have been identified and isolated, they're then benchmarked against a larger data set, either a user-defined data set or a data set defined by Lawrence Berkeley National Lab. We've created databases for the U.S. commercial stock with a sample of buildings that offers representation across across all U.S. climate zones and across all size levels for U.S. buildings, and also for U.S. for U.S. K through 12 schools. So what Better is essentially doing is again isolating, identifying coefficients, and then benchmarking them against the median and standard deviation for those same coefficients derived from a larger data set. Once that's complete, a user defines a retrofit target savings level or an energy savings target level, anywhere from aggressive energy savings to more conservative energy savings. We apply Johnson Controls intellectual property and better identifies energy efficiency measures and also quantifies the energy costs and greenhouse gas emission reduction potential for a building and the entire portfolio of buildings being analyzed. 2 reports are then generated by Better. One that shows on an aggregate level overall portfolio energy cost, greenhouse gas emission reduction, combined with the top 5 energy efficiency measures for that portfolio, as well as information to allow for ranking and comparison of one building to another building in that portfolio in terms of electricity consumption, fossil consumption, and cost savings potential. Additional information is provided for each and every building in the portfolio, and we'll get into more detail when I do a live demo of Better. So again, as I mentioned, Better is designed to be easy to use, and part of that means that we've tried to use as few data points as possible in order to allow for the quantification of energy and cost savings in a building and the specification of EE improvement opportunities. The data that's required to analyze a building in Better is a smaller data set than that required by Energy Star portfolio managers. So this is one of the advantages of Better. We require a building identification number, the location for the building, could just be city and state or a postal code, gross floor area, excluding parking, primary building space type, which just refers to the space type that accounts for at least 50% of the overall building gross floor area, and currency, which allows Better to determine in which currency are potential cost savings communicated to the user. In terms of energy data, Better requires at least 12 consecutive months of energy usage for all fuels used in the building, including the monthly billing start date, the monthly billing end date, energy type, energy unit, the monthly energy unit usage amount, and monthly energy cost is optional. It's encouraged because it will allow for greater accuracy in the estimated cost savings available from energy efficiency improvements. But if a user doesn't have cost information, Better will pull that information from proxy fuel price databases that we pulled together for the United States. Also optional is average daily outdoor air temperature for the billing period. Most often users won't input this information, which is not an issue. Better is pulling that data from the National Oceanic Atmospheric Administration weather database. So with that, I want to talk more in depth on the process for Better to quantify the size of the energy efficiency opportunity and the energy efficiency measures needed to capture those savings. So the way Better works, it's going to read the building information input by a user, the address, the space type, the floor area, and the monthly energy usage information. Better will then search for the closest weather stations, and at the same time, it will be combining different types of fossil fuel consumption and converting that energy consumption into a single unit. On the back end of Better, we use KWH, but when we report out to users, we report either in KBTU or KWH, depending on whether a user wants to work in standard international units or imperial units. Better then downloads the appropriate weather file from NOAA, and it normalizes energy consumption to show the average daily energy use intensity for a building for the last 12 months and aligns that with the average daily outdoor air temperature for those same previous 12 months. With that, Better will generate any of the 4 following models, these schematics, these inverse models, which I mentioned earlier. And you can see in this graphic here the model types, the schematic plots, and the coefficients that can be derived from those schematic plots, and a brief interpretation of the schematic. So I'm just going to take the example of the 3P cooling model very quickly. And again, we're looking here at a plot of the average daily energy use intensity as compared to average daily outdoor air temperature. So that horizontal line segment, the portion that you see there in the 3P cooling model represents, let's say, cooling baseload for a building, or the baseload for a building rather, which is a combination of a building's lights, plug loads, and process loads. The slope coefficient, that A1 there, is a function of the building's envelope integrity, the ventilation infiltration air, and the efficiency of the mechanical cooling system. And then that point, C1, the change point or the break-even temperature, is a function of the temperature set points in the building. So as a result, what Better allows us to do is to evaluate energy savings opportunities in buildings. For example, if a model shows that the cooling sensitive coefficient is quite high, this may mean that a building's cooling system requires maintenance or replacing. Again, we can talk about this more in the Q&A section if there are questions, but this is the basic science behind Better, which allows us to quantify cost savings and identify the EE measures. Okay, so once an inverse model or a couple of inverse models have been developed for a particular building, Better develops a model for the electric consumption and a separate model for the fossil consumption. Better next will benchmark those coefficients. So let's take the example of electricity baseload. So Better has determined the electric baseload for a particular building, and it's going to benchmark that against the median and standard deviation for electricity baseload for a larger data set of buildings, either a user-defined data set or a data set developed by Berkeley Lab. If the electric baseload for this one particular building is better than one standard deviation from the median, we would consider that to be good electric baseload performance. If that electric baseload coefficient for that individual building is worse than one standard deviation from the median, in this case, higher than one standard deviation from the median, it's considered poor. Everything else is considered typical. In general, lower coefficient values are better, with the exception of the cooling change point, where we'd like to see a slightly higher temperature at which the building engages its mechanical cooling system. In this example, the electric baseload is determined to be better than 2 standard deviations from the mean. It's considered to be good. Better applies this methodology for all 5 coefficients of performance for electricity and all 5 for fossil. And you can see in this lower portion of the slide here how this particular building that we're analyzing performs relative to the underlying database for all 5 coefficients for electricity and all 5 for fossil. So in some areas it's performing well, in others there's opportunity for improvement. For example, fossil heating sensitivity and and electric cooling sensitivity. All right, so as I mentioned, a user needs to specify the energy efficiency target as part of Better's overall analytical process. The user can define the energy savings level as aggressive. It means they're looking for deep energy savings, whereby Better sets a target coefficient level as half a standard deviation better than the data set median, a nominal target, which in this case is equal to the data set median, and thirdly, a conservative target, where a user defines the target level of energy performance for each coefficient as 1 standard deviation worse than the data set median. Next, Better is going to define the facility improvement measures or energy efficiency measures necessary or recommended for a particular building to improve performance. So let's take the example of electric baseload once again. Example A, let's say the electric baseload for a particular building, the model coefficient is determined to be in the poor range. The target that a user has set is nominal. Because our target is superior to current performance, Better would select appropriate facility improvement measures to improve that electric baseload. That might be recommendations for improving lighting efficiency, for example, in the building. I'll talk about that more in a moment. In the second example, the current model coefficient for electric baseload in a building is found to be typical as compared to the underlying data set. The target level that has been established is conservative. Since the target is worse than current performance, there's no need to select energy efficiency measures. So Better won't recommend anything to improve electric baseload. All right, so energy savings estimation. Once the facility improvement measures have been identified, Better then calculates potential energy and cost savings. So we'll take the example of heating sensitive consumption. And let's say that Better finds that the current heating sensitive consumption for a building is worse than the target. You can see that's a very steep slope as compared to the target, which is a bit more gradual. So some facility improvement measures or energy efficiency measures are suggested to reduce that heating sensitivity. A new change point model is developed by Better with the new and improved coefficient for heating sensitive consumption. Better will rerun the model to get the estimated energy consumption associated with the new model coefficient. It'll take the current energy consumption for the building, subtract from that the estimated energy consumption for the building, assuming all recommended facility improvement measures are being implemented, and assuming we're moving to the appropriate target model coefficient for all of the 10 coefficients we've been discussing, and then calculate estimated energy savings. With that, it'll then associate, it'll calculate an associated energy cost savings based on either the utility bill information input by a user or proxy fuel price information. Here I just show how the model coefficients for a particular benchmarking exercise would map to the specific energy efficiency measures recommended by Better. At this point, Better suggests up to 14 energy efficiency measures. These are sort of broad categories. We've developed more granular training information for users, which break these down into about 25 no-cost, low-cost operational improvements that can be implemented by building operators to capture savings immediately, and about half a dozen or so investment-grade energy efficiency improvements. But the way this works, again, so we've been using the example of electric baseload. Let's say a building has a high electric baseload. Better is going to recommend measures such as reducing equipment schedules, reducing lighting load, reducing plug loads. In another case, let's say a building shows a low cooling change point. Better may recommend increasing cooling set points, adding, fixing economizers, or upgrading the windows in the building. So it's a little mapping of the model coefficients to the EE measures. So now I'd like to do just a quick live demonstration of Better. And I'll move quickly here. I know we're almost out of time, so bear with me while my computer moves here. All right.
Fine, Carolyn, don't worry about it.
Okay, great, okay. All right. Okay.
And I want to note while you're doing the transition, we will have, if you're willing to go to the Meet the Speakers section after this, you can talk with.
Oh, definitely.
And then I think we are offering this so that people, instructors and others can try it out. You have a sample data set and so forth.
Oh, fantastic. Great,
right.
Great.
That was my understanding. So this is the first chance to see how it works.
Excellent. Okay. So this is the Better homepage, and I just will mention we were recognized with an R&D 100 award earlier this year, recognizing Better as one of the 100 most innovative and disruptive technologies of the year. We also received a Lawrence Berkeley National Lab Directors Award for Tech Transfer because of our partnerships with industry to both develop and validate Better. So here's our homepage, a little bit of information about Better and value to users. We also have a page, How It Works, which provides a little bit of explanation again on the change point models, the inverse models, the benchmarking, the derived EE measures, and the cost savings. And we've got a nice YouTube tutorial. It runs about 10 minutes to learn how to upload data and analyze buildings in Better. Some of our publications, and then lengthier training presentations. These are both in English and Spanish and provide information on how to develop a quick win strategy to improve portfolio energy performance in buildings, etc. For those that are interested, we also have application programming interface, which would allow for users to integrate Better's analytical capabilities into their own software platforms and tools. So please just contact us if you're interested in using the API. We're using a JSON schema, and we've got examples here, and I think pretty good detailed information on how to transfer data using our API. Also, Better has an analytical engine that's open source. So you can also access the Github Repository to download and access the source code for Better. We've got licensing and copyright information here. The only requirement is that any software developers that make enhancements to the Better web app analytical engine source code, we just ask that they share those enhancements back with the Berkeley Lab development team, so the public access version of Better can continue to be enhanced and improved. Finally, we've got news section and frequently asked questions. So interesting press information, use of Better. We're excited to see that the tool has been taken up in the marketplace fairly widely since we launched the beta version in May. So getting into the actual running of Better, there's a tab here called Run Better. You click on that and you'll be taken to this page. There are a couple of different options for uploading data. You can either use our Excel-based data entry template, which I'm showing here on the screen. We have instructions on how to input data, really simple inputs. I've really gone over these in the training earlier today, but again, we're just looking for building ID, location, floor area, and space type. And in terms of the utility data, again, the past 12 months minimum for all energy types used in the building. And here I'm looking at a large portfolio. This is a sample set of buildings from Washington, D.C. And I'm going to show you how Better works to run data. So the other alternative way to enter data into Better is to follow instructions for downloading an Excel-based report with generated by Energy Star that has all data required for a Better analysis, and then uploading it to Better. If you have data in Portfolio Manager, this is an awesome and easy way to get that data into the Better analytical tool. I've done this a number of times. It's so easy. It's thrilling. So anyway, just indicate the type of template you're using to upload data, either Better template or the Energy Star template. You then need to select the building type you're going to analyze. In this case, we're just looking at offices. From there, you'll come to this page where you'll be allowed to select the savings target level. And as I mentioned, there are 3 potential savings target levels. We're going to choose nominal for this demo. The benchmark statistics, which are either a default benchmark statistics, which are those that were developed by Berkeley Lab for either U.S. commercial office or U.S. K-12 schools, or Better will generate benchmark statistics based on the data you've input via the spreadsheets I mentioned earlier. Also a minimum R-squared value, our default is 0.6, but a user can play with that a little bit and you'll see how it affects the energy and the cost savings levels. But 0.6 as a general rule of thumb is a good starting point for analysis. You click Run, it'll perform the analysis, and then you click on the Portfolio Output Report, and you'll come to a report like this. So this is, we're analyzing a portfolio of DC office buildings. We're looking at 26 offices, total floor area of 6 million square feet, 6.4 million square feet. Better identifies about $2.5 million in cost savings, 21%. 18% energy savings. You can see the breakdown between electricity and fossil here, and also greenhouse gas emission reduction potential. Additional metrics on the energy, greenhouse gas emission, and cost, both usage and savings for the portfolio are shown here. And then the top 5 energy efficiency recommendations for the portfolio. And I love this because if you're a city, if you're a state, if you're a large corporation, you can very quickly understand the several things you could do across your portfolio, leveraging efficiencies of scale to capture these cost and energy savings here above. Many of these are no cost, low cost to implement, which is also wonderful. So we identified the buildings, we provide a short description, and then resources on how to implement measures, implement the steps necessary to capture these savings or implement these measures. Also, a benchmarking chart here, which shows each and every building that you've input into Better for analysis, and you can play around with this a little bit to compare one building to another in terms of electricity use intensity. You can very quickly find your laggards and also some of your leaders. You can add on top of that fossil or look at that separately. And then over here on the right, y-axis for this graph, you'll see the savings potential. And again, very easy to pinpoint those buildings that warrant further studies, site assessments, audits, or those buildings that indeed are performing well and offer lessons and best practices which could be shared across the portfolio to help improve portfolio energy performance. So that's the benchmarking graphic here. Here's a sortable table which shows each and every building you've analyzed and allows you to kind of rank based on annual cost savings or annual energy savings, allowing you to quickly select buildings that you'd like to further analyze for energy efficiency improvements. So I've selected 1775 K Street. This is a building in Washington, D.C. We see about $28,000 cost savings potential, 11%, energy savings 16%. We show the same details in terms of energy, greenhouse gas emissions, and costs, both consumption and savings potential. Here's the target we've selected, nominal. Here are the energy efficiency recommendations for this building. We also see a cost breakdown. So this is, how is this building currently, how are its costs divided across base load requirements in the building, cooling requirements, and heating requirements, what a typical building is using for a particular data set, and then where the goal is for this building. Also here, cost savings breakdown. So most of the cost savings that Better is predicting would come from improvements to the cooling efficiency of the building. Consumption trends, so the yellow line showing current monthly energy consumption for both electricity and fossil, and green, improved consumption levels, assuming this building implemented the recommended energy efficiency measures. We show here the weather sensitivity and benchmark. So these are the change point models. You can get a really good sense, again, for the last 12 months, what's been the average daily outdoor air temperature and what is that meant in terms of average daily energy use intensity for that month. And then you can see the model fit to those lines, the benchmark analysis for each of the coefficients, and we do the same for fossil. Here we show the energy efficiency recommendations for the building, including the specific measure and recommended resources to support implementation of that measure. So in a nutshell, those are the reports, both the portfolio and the building level report. And now I'll just go back to the slide set here, and I think I've got another couple minutes, and I'll just show you very quickly. As I mentioned, we've had success with the introduction of Better into the marketplace. We now have 400 trained users across 33 countries using Better, most of those in the United States, of course. We've also had incredible engagement from industry, and I'm showing here on this slide key industry partnerships, including ESCOs, large corporate portfolio owners, school districts, cities and states, federal agencies, market transformation programs, and of course, associations and universities. And as I'm having the opportunity to present to Lainey Best today, I will just mention that we've been approached by Florida Gulf Coast University to develop or co-develop a training to prepare the next generation of cloud and field-based comprehensive energy workers on use of utility bill data and remote energy analysis to spot energy efficiency opportunities in buildings. And so we're very happy to talk about something similar to be undertaken with Lainey, if that's of interest. Again, lots of activity, applying better. I think what's exciting is that we see better being deployed not only at small kind of sole proprietor level ESCOs, but also some of these large corporates like Amazon and Blackstone are showing interest. Finally, some testimonials. And I think I will just briefly say here that some of the reasons that Better has resonated with audiences that I mentioned earlier has to do with its simplicity and the power of its analytical inputs. And you can see here, Prince William County Public Schools is using Better. They're happy to have this remote energy analytics approach so they can cut energy costs and divert more of their operating budget to into classroom educational improvements. Energy resources integration, it's a ESCO company, is finding this tool to be quite valuable, particularly when they're not able to carry out on-site assessments due to the COVID-19 pandemic. Judicial Council of California is using this across 450 courthouses. I love what they're saying about this. It gives them
Carolyn,
prior to visiting. Oh, yes.
Carolyn, your audio cut out for just a minute. I'm going to take a moment just to ask the question, one of the questions that we have come in here. I think
sure.
the people who've been listening are very, very interested, very excited about this. But the question is, someone here has used asset score, which gives some very generalized results. They're, you know, it seemed like a good idea, but it was nice information, but nothing to indicate specific changes that are needed. Can you compare this, if you know anything about asset score, or if you can describe how this gives actionable results that can be applied within the context of the space?
Sure. Yes, so I am familiar with asset score. My understanding of asset score is that it evaluates the physical characteristics of a building. And so regardless of how equipment and systems are consuming energy, it's simply going to give a ranking for, if you will, the quality or the energy efficiency levels of equipment and systems. So Better is distinct because it actually is evaluating the actual operating energy use of a building. That's its differentiation from the asset score tool. So in terms of recommending actionable actions that can be taken to improve actual operating energy use in buildings, yes, that's Better's focus, and it's meant to do that. It's meant to give information on how to immediately improve actual operating energy efficiency in a building, and it provides stepwise guidance on how to, for example, if Better recommends reducing lighting level consumption or improving the efficiency of lighting in the building, the Better training materials will say, okay, here's 5 things you can do: delamping exercise, installation of low-cost occupancy sensors. In general, we try to make Better designed for, again, those quick, no-cost, low-cost operational improvements to really cut energy bills, that cut your energy bills. So I think it's worth taking a look at Better. It's quite distinct from asset score. I know asset score. We compared Better to asset score. We asked users to take a look at asset score, take a look at Better. By far and away, they liked the outputs generated by Better a lot more because of the action orientation and because of the simplicity of the implementation.
Oh, that's great. And that leads directly into the next question. One of our participants, one of our attendees has asked if there's any availability offline to discuss Better and how to, and its integration or inception. And I think
Sure.
so they can either email you at LBNL, which can be frustratingly slow, or we have a better option. We have Meet the Speaker afterwards. Are you available
Yes, that's right.
to go into the Meet the Speaker space and help them find how they can get a test run of this and be able to
Oh,
practice
sure.
use this? And I also would suggest that we also have a lot of instructors here from community colleges. Can students use this to do their homework?
I hope so. You know, we have been approached, as I mentioned, by both ASHRAE, the association, the professional association, to incorporate Better training into their guidebooks, but also universities. And there's a proposal that we've developed with the state of Connecticut, or the state of Connecticut has developed it, to actually train community college students on how to use Better as part of a program that would go into cities across Connecticut and try to identify opportunities to improve energy efficiency in underserviced communities. A focus would be on identifying buildings that use fuel oil or number 2 heating oil, Janie, which is one of the most polluting high GWP oils on the market today, and replace those furnaces and boilers with high efficiency heat pumps.
Oh,
so I would say we would love to do something similar here in California with a community college if there was interest in that. Yep.
And we have community colleges here from across the country.
Okay.
One last question, and then I will explain. Let me jump in real quick. To go to the Meet the Speaker space, you go back into the auditorium, and across the bar on top, there's a place that has chat rooms. Go into the chat room, and Meet the Speaker should be under there. Our last question is, who tends to use Better? Is it executives, property managers, building engineers, basic building staff, other people, students who want to get answers?
Oh, that's a great question. Yeah. You know, in general, I think we've seen a large uptake from ESCOs. So those companies that are looking to, in fact, sell energy services. And then we also see a lot of uptake from facility managers, or particularly.
I'm not sure why your audio cut out, Carolyn, but it did just for a moment.
Better, Janie, at all?
Yes, it is.
Okay, I'm so sorry about that.
We have to wrap this up because we have another talk starting in just a couple minutes. I'm told that when you go into the Meet the Speaker chat room, you can try the phone video options by clicking on the person's name, and that should help. But there is, as a backdrop, there's a text option back and forth. So I think we will have a lot of options there, and there's clearly a lot of interest. So folks who are in this session right now, you have choices. You can go to the next section, which is also a tool talking about how to simulate building controls. Or you can go over and Meet the Speaker and talk a little further with Carolyn Szum. So thank you very, very much. And we will move on to the next session in a couple of minutes. Thank you.
Great. Thanks, Jamie.